Hello, and welcome to 5 Minute Math. Today we are looking at the sixth grade STAAR test 2025. You can follow along using the custom statewide item analysis report that I made using the tiny URL or the QR code on the screen. If you would like to jump ahead to any specific item, you can use the timestamps you see on the slide, or you can use the bookmarks by pulling up on the video and using those that are on the bottom of the screen. For number one, we are looking at representing ratios and rates. This is 6.4e, and this is going to be quite as easy as it seems. We've got 35%. We need to find a decimal that represents 35%. When we are dealing with ratios and percents, typically we get some type of challenge because the decimal might be in the fraction, but in this case, we have 35%, which is 35 per cent. This percent means per 100. So 35 per 100 is the same as 35 hundredths is the same as 35 hundredths. Or we could just move the decimal over twice to the left. Now we have to find the decimal. If it's not there, you can always put it after the ones place. You move it over twice to the left, and that ends up becoming a hack. Either way, yes, this is as easy as it seems. And we had not 100%, but as high as I've seen on a STAAR test, 85% of our students get this correct, and the rest were just already guessing. And this is the first question of the test, and so you want it to be easy, but this is the easiest by far item on the test, and so it just gets more difficult after this. For number two, we are looking at operations with integers, and this is 6.3d. And we've got this story problem, but really what it comes down to is we've got a list of numbers, positive and negative, that represents the change, and we need to find the total. And so really what we need to do is we need to just add these numbers together. We've got positive 8 minus 6 plus 2 minus 5 minus 1 plus 3 minus 6. So there's a few different ways we could do this. One way I'll keep up with it would be a number line. And so let's just start with 8 right here. All right, so there's my positive 8. If I do a minus 6, it's going to get me to 2. If I do a positive 2, I'm going to jump back up here to 4. Minus 5, this is where it gets tricky. I've got 1, 2, 3, 4, 5. Now I'm in the negative. So that's negative 5. Minus 1 gets me another negative. Now I've got to go positive 3. Okay, so I'm at negative 2 right now. 1, 2, and then let's get another one right there. Now I'm at 1. That's a positive 3. But now I've got to go negative 6. Okay, well, let's start at positive 1. Let's go 1, 2, 3, back the way we came. And an extra 3 more is going to get me negative 5. So that's one way that we can look at it. Another way would be just to take all your positives, right? And let's say 8 plus 2, 8 plus 2 plus 3. That's going to be 13. And then a minus 6, minus 5, minus 1, minus 6. This also works. So that's going to be minus 18. And just doing one big jump, 13 minus 18, there's your negative 5. By the way, our students did a decent job with this one, 75% correct. So this was the fourth easiest item on the test, and that's pretty typical. We will normally get some softballs in our first two questions before things start picking up. Number three, we are looking at ratios as division. This is 6.4d, and we've got a school counselor sorts 875 students into 35 classrooms. And so we get the same number of students in each classroom, and then we need to find a rate. Well, that looks like division. So let's do, if we want to show it, we've got a strip diagram here. There's my total. So we need to recognize we've got our total. And then we've got equal groups. When we have a total and equal groups, that means we're probably going to divide. So they're going to have us look for either the part or the number in each part. In this case, we've got 35 classrooms. So let's just pretend that's 35 times. So I'm just going to divide. Let's divide 35 into 875. So 35 times 2 is going to get me 70. And then that's going to be 175. Let's see, times 2 is 70. So times 4 is double that, 140. And then times 5 is going to give me that last one I need. There you go, there's my 175. Now, labeling, because look, I've got students per classroom, classrooms per student. Let's make sure we label it. Do we think we are going to have 25 classrooms per student or 25 students per classroom? Well, if I say it like that, it does make sense to have students in a classroom. You don't have classrooms per student, you have students per classroom. And so most of our students were able to not necessarily fall for that trap because you get your 25 and you hit the first 25. If you take a look, only 8% of our students chose A, which is not that different than the amount that chose B or D. So we did fairly well on this. And in fact, this was our second easiest. So within the first three questions, we had our first, our second, and our fourth easiest item. Well, the honeymoon is over because now we're on to number 4. This is 6.10b, determining the validity of equations and inequalities. And this one is going to be a little bit more challenging. And so let's take a look at it. We need to find an inequality that is true for all values of where n is. All right, so here's my number line. If that's my 0, I'm going to make my -3. I cannot include -3, so I'm going to make an open circle, and then I'm just going to darken that right there. Anything smaller than -3 to the left of -3. So what's going to make the most sense is that I choose the closest integer to -3 that is available, and that is going to be -4. Now I can choose anything less than -4, like -100, -1,000,000, but let's do -4. And then what we need to do um, is we just need to go ahead and, let's just plug these in. And so let's see, -4 plus 5 is less than -6. -4 plus 5 is like 5 minus 4. So that's 1 is less than -6. No, that doesn't make any sense. One is greater. All right, so let's try over here. -4 plus 5 is greater than 3. So that's going to be 5. Same thing. Every single one of these, take a look at this, is going to be that n plus 5. So that's going to be 1 is greater than 3. Nope, 1 is less than 3, so that doesn't work. I'm just going to do the same thing right here. It's 1 is less than -1. Now that doesn't make any sense. 1 is greater than -1. But I could do this one. 1 is less than 3. Finally, we have an answer. Now, that was a lot more difficult. Take a look at our answer choices. So we had 35% get this correct, 29% choose B, 21% up here, and then 17% choose C. This makes me think that we have an awful lot of guessing going on in probably most of the 35% that chose D guessed, and they just happened to guess right, because when you see the answer distribution that close together, that means students didn't feel like they had a real good chance to access that. So one opportunity for students is to just find a number that fits, so less than -3, and plug that in. Another thing we're going to do is we are going to, when we get into upper grades, we're going to solve these inequalities using the properties of equality. And what we could do is on any of these, let's take this first one, you can actually subtract 5, right, from both sides. Now you still need to find an n, but you could have done n is less than negative 11, and then we still plug in that negative 4 just to see. Ends up doing the same thing to see if this works, and this is going to be a method that uh, we're going to use in upper grades. Most likely substitution is going to be the best bet right now. For number 5, we are looking at 6.14b, which is debit and credit, and this is a match table grid. So we're just going to select debit or credit for any of these here. And so we need to know the difference. So a debit card and a credit card look very similar. They could both be Visa or MasterCard. This is tied to your checking account. So if you use your debit card, that money comes immediately from your checking account. And if you don't have it, you can't buy it. And the credit card is basically a small ongoing loan. You are asking the credit card company to pay the merchant for you, and then you pay the credit card company back. So, what builds credit history? What can positively affect a person's credit score? Well, a credit card is what builds your credit history because it shows that, and they track how often you pay your balance, how often you make late payments. The former is good, the latter is bad. Money used to purchase an item is automatically withdrawn from a bank account. That is a debit card. You have to have that money in there. Each purchase is a loan paid back in the future. That is our credit card. And you may be charged interest. Well, that's a credit card if you don't pay it off by the end of the month or by the end of the statement period. So we had 3 credits and 1 debit. Now, this is simply a 2-point item. And so if you get 3 or 4 correct, you're going to get 2 points. And only 34% of our students got that. If you get exactly 2 correct, you're going to get 1 point, half credit. We had 44% of our students get that. So this was kind of a struggle for some of our kids. And if you get 0 or 1 correct, you don't get anything. You get 0 points, 22% now. If we take our half credit 44, with that to 34, we get 56%. If you take half of 44, it's 22. So 56% overall correct. This was right in the middle of the test, 16th easiest, or tied for the 16th easiest. It's one that we don't pay a lot of attention to, these personal financial literacy, but some of our students might have been one question away from the next performance band, and a little bit more time on debit and credit not only would help them in future, just day-to-day living, but also might help them on a test like this. For number 6, we are looking at real-world ratios and rates. This is 6.4b. And so we have a floor that's got 2 different tiles. We've got this ratio. All right, so they're going to give it to us green to blue. So let's go ahead and write green to blue. And then they give us the numbers there are going to be 7 to 13. So let's go ahead and put that there. All right, so 7 to 13 is our ratio, and then we simply need to find one that kind of matches if we have a total of 3,000. All right, so we've got a few different ways that we can approach this. We're looking for blue, so let's specifically think of blue. All right, so when we are thinking of green to blue, we can actually add a third if we want to, and this could be our total. So think of it almost like a table of values, right? If you have 7 green for every 13 blue, that'd be for every set of 20, you got this ratio of 7 to 13. Now what I'm wanting to do is I'm wanting to get to a set of 3,000. Do we see how our ratio almost builds itself? Our proportion, right? we can view it like this. I'm wanting to know how many blues there are if I've got 3,000 total. So I needed the green just to get my total of 20, but other than that, I don't really need it. So now we could just go ahead and do our cross multiplication. And I'm going to change that question mark to x. We'll say 20 times x equals this 13 times 3,000. And like I said, this is just one way to solve it. You might have done it slightly differently. So 13 times 3,000 is going to be 39,000. And then we're just going to need to divide that by x, or divide that by 20, excuse me. All right, so let's go ahead and at least get rid of the 1 0 each and divide both numerator and denominator by 10. So now I've got 3,900 divided by 2. So let's do that. 3,900 divided by 2. Let's see, 19 is going to be 9. And there we go. We've got that 5, but we need to go ahead and make sure we also get that last zero in there. 1950, 1,950. That is at least less than 3,000. All right. So that is our answer, A. Now, not many students were successful with this. We had 45%, less than 50, get this correct. We had 11% choose B, 15% choose C, and then 28% choose D. Now, it might seem like a random number, but you can actually get that if you take your original ratio, 7/13, and then you multiply it by 3,000. You have to do a little bit of work. We're now dividing by 13, which no one really wants to do that. But if you take your 21,000, divide that by 13, that's what you're going to get. So these students were at least thinking proportionally, but they weren't necessarily setting up the complete proportion. Because really what we needed was we needed a number that wasn't included. We needed 20. Since we're looking at the total number of tiles, and they didn't give us the total, they gave us the green and the blue. So it's that hidden number that made this difficult. In fact, this was the tied for the 14th most difficult item on the test. And so that's something that we need to be thinking about when we're setting up these real world ratios and rates. They might give us a green to blue, but if they're asking for the total, that means there is a third number that we need to calculate. We need to add the two to get that subtotal so we can use that 20 with our 3,000. For number 7, we are looking at classifying number sets. This is 6.2a, and we've got our Venn diagram here. And we need to find a number that is not going to be located in the shaded region. All right, so not. Now, some of these are going to be classic. Some of these are going to be a little bit tricky. Looking at C and A. Every time you see a fraction, you need to be suspicious because if you can simplify it, it might not end up looking or landing where you think it is. Because you would think, okay, it's not an integer. You would think this is a rational number right here. You would think. But if you thought that, you would actually be incorrect. Because if we simplify negative 8 over 2, that's negative 8 halves, that actually simplifies to negative 4. So in fact, that is an integer. And it does belong. We're looking for what does not belong. It does belong in there. So I'll write negative 4, but really we need to just think of it as negative 8 over 2. So we need to simplify. Now, obviously, we've got our negative 33. That's going to go there. Let's skip over this because this is the most easiest to kind of recognize. There's our 2. Now, 2 is going to be a whole number. But here's my question. Is that inside the shaded region? Well, my integers, remember, are shaded. I'll use blue right here. Shaded right here. But the shade actually includes whole numbers. Everything within the integer, including the whole number, it's still an integer. So technically, this blue includes the whole numbers, which means my 2 is an integer. It's just a special type of integer called a whole number. The one that doesn't belong is this 11 eighths, 1 and 3/8. That's as close as we can get it. that is not an integer. That is going to be a rational number. So we can call it 1 and 3/8. We can call it 11/8. That's the one that actually does not belong. But this one is extremely tricky. And we only had 42% of our students get this correct. We had 32% choose this. And I get it because it is a whole number. So it's not in the shaded region that you can see, but it's that relationship between the whole numbers and the integers. We need to know that all whole numbers are, by definition, integers because they're a smaller square within the larger square of integers. We had 16% of our students kind of get tricked on that. No one really fell for that -33. This was tied for our 11th hardest item on the test. And so there's a few things that we need to keep in mind as we're working with our students on 6.2a. First, the students didn't necessarily fall for it too much, but let's still do this, right? Let's still do either a negative integer like that that looks like an improper fraction, or you might do something like this. You might do like 200%, right? Or negative 200%, right? And then that would be actually just -2, right? Different versions of integers that they have to simplify or they have to rename to see whether or not they're integers. But the biggest question is this conversation about these whole numbers and the integers, and you've got a smaller set in there called natural numbers or counting numbers that just simply are all the whole numbers except for 0. And so we need to have these conversations about if I'm asking for an integer, something inside that whole number box is by definition still an integer. Number 8, we are looking at representing additive and multiplicative relationships. This is 6.6c, and we've got a drag and drop here. We need to put some equations on a table and a graph here. And so let's see what we have. Let's start with our equation. Okay, so what's happening with our equation over here for our table? We'll start there. Well, we're getting smaller. Okay, so we are either going to subtract or we're going to divide. But you know what? Let's start with division, because at this point, most of the time, that's probably we're gonna end up more and more being subtracting less, and more we're going to be dividing and multiplying. So let's try dividing. How do we get from 8 to 4? Well, I can 8 to 2, I can divide by 4. Can I do that all the way down? Does 12 divided by 4 equal 3? Yes. 16 divided by 4 equal 4? Yes. Okay. So I need to divide by 4. But don't see a divide by 4, right? It needs to be a y equals x divided by 4. Well, something we learn in 6th grade is that dividing by a whole number is the same as multiplying by the reciprocal. So we need to think about that as well. And what is a reciprocal of 4? Well, you just flip it upside down. It's 1 over 4, right? You make it 1 over, and then you keep your number, your whole number, as your denominator. And really, we would always put that multiplier first. So it's going to be 1/4 x. So we had to first think of divide by 4, and then remember that multiplying by a reciprocal, that's the same thing. So we can say y equals 1/4 x, and don't let this trick you because it's the y. Look at these x's and y's are flipped. So I don't see y equals 1/4 x. What is another way to represent that? Well, we can also represent that as x over 4. So that's going to be x divided by 4, right? Is really what this is. That's just a different way to do it. So we need to be able to see it in any of these three formats. 1/4 x, x divided by 4, or x over 4. In this case, y equals x over 4 is going to be the one that we need. But we need to be flexible with all of them. All right, so I'm going to make a table of values here just because that's going to be a little bit easier for me to check this second one. So I've got 0, 0. I've got 1, 2, 2, 4, 3, 6. Once again, I'm going to start with multiplication since we're getting bigger. Let's see, times 2 times 2 times 2. Okay, that's going to be easy. Y equals x times 2 or 2x. And then we can just put that right there. So there we go. That is our problem. This is a 2-point problem. We had 43% of our students get both points, 29% get one, 27% not get any. So if you put these together with that half credit, you're going to get 58% of your students get it correct. Not bad. I mean, it's kind of middle of the road. It's almost that 60% which we're looking for. But this is a little bit on the easier side. 14th easiest. Honestly, I am guessing that the challenge was this right here. Because look, I started with equals x divided by 4, and then y equals 1/4 x, and that still wasn't even it. So I had to go to y equals x over 4. And this is definitely a challenge right here. I bet you some students chose that because they saw that 1/4, and that was it. There's just a lot of different things that we can do here to help our students be successful. For number 9, we are looking at summarizing categorical data. This is 6.12D. Got a percent bar graph here. And we need to evaluate 4 statements. Now, before we do this, let's look at our key. Let's put some numbers on here. Let's make sure we've got this. From 0 to 10 is easy. All right, so this 5 a.m. is going to be 10. But this 6 a.m., which is the slightly lighter shade of dark, goes from 10 to 55. So we need to subtract those two. And that's going to get you 45, not 55. It ends at 55, but it doesn't start at 0. It starts at 10, so you can't just say, oh, that's 55%. Now I've got 80 to 55. That's going to be 25. And then I've got 80 to 20, or 80 to 100, that's 20. That's kind of easy to eyeball. Now, before I move on, this is what I suggest. Let's add all these. Make sure it equals 100, because if my percent bar doesn't equal 100, then I've done something wrong. That's 5, that's 10. There we go. So we need to know that I've got these 4%, they equal 100 because the percent bar graph goes up to 100. Now I can evaluate each of these. I'm going to take these statements and turn them into algebraic expressions here, or algebraic equations. More than half of the students, so I'm going to say greater than half the students attended the 5 p.m. session. Okay, well, half would be 50, right? 50%. What's my 5 p.m.? Well, that's only 25. So it's 25 more than half or more than 50. No, it does not work. Now, the 5 p.m. does go to this 80. So if you're not really reading this correctly, you might think, oh, 80 is definitely greater than 50. But it doesn't start at 0, so you can't say it's 80. It just happens to end there. All right, so fewer students attended a morning session than attended an afternoon session. Okay, so what are my morning sessions? All right, so 10 plus 45 are my AMs is fewer than my PMs, 25 plus 20. So I'm turning this into an inequality now. So that's 55 is less than 45. Nope, that does not work. Fewer students attended the 6 p.m. session than the 5 p.m. session. Okay, so 6 p.m. is 20, and that is fewer than the 5 p.m., which is 25. All right, that works. So let's just verify that D does not work. All right, so more than twice as many students attended the 6 a.m. That's 4:45 attended the 6 a.m. than the 5 p.m. Okay, so that's more than. So this 6 a.m. session is more than twice as many as the 5 p.m. So that's twice as the 25. Is 45 greater than 50 or twice the 5 p.m. session? No, it's not. All right, so Our answer here is C, and that was a lot of evaluation. We had to read each of these step by step, and we had 42% of our students choose this, and we had 40%. Look at D, 40%, almost as much as those that chose the correct answer chose the incorrect answer of D. So let's look at D real quick. What makes that so alluring? Well, probably it was the hardest one to evaluate because you had the more than twice as many. So I had to double one. But if you look at the 6 a.m. session, the 6 a.m. session, it's this one right here. And if I'm not paying attention, I might think the 6 a.m. session is 55 because it ends at 55. Now we know it's only 45 because it starts at 10. But if I were to replace this 45 with 55, you see how that works? So the first thing we need to do is we need to make sure that our students are getting the number of values for, in this case, making sure that they add up to 100, and then using those numbers, not these percents that you see up here, to evaluate each of these statements. Number 10, we are graphing on the coordinate plane. Now, in this case, there is no coordinate plane for us to look at, and so we're going to have to use something that we draw, or maybe just some type of verbal description. 6.11a. So I'm going to draw a quick sketch because there's nothing wrong with doing that. So let's do this. Let's draw my 4 quadrants. Point Q is located at 2, -4. So that means at +2, -4. Let's say it's right down here. 2, -4. Now, point V is 4 units away. We don't know in which direction, but there's 4 directions I can go. I could go up here 4, I can go to the left 4, I can go down 4, and I can go right 4. Which ordered pair could it be? Well, let's put some values on each of these. If I go to the left 4, that means I'm changing my x value, and I'm subtracting 4. So this is going to be 2 minus 4. The y value stays the same, so that's going to end up being -2, -4. Okay, so I see this. If I go down here, I'm changing the y value. So this is going to be 2, and then -4 minus 4, right? So that's going to be 2, -8. Don't see that. Okay, so that's not it. I'm changing the x value on this one right here, but I'm adding 4 because I'm going to the right. So this is going to be 2 plus 4, -4. So that's going to end up being 6. +6, -4. Don't see that. And then I am subtracting, or excuse me, adding 4 to my y value. So 2, -4 plus 4. So that's actually going to be 2, 0. So actually my dot should probably be right there. I see a 0, -2. I see a -2, 0. I don't see a 2, 0. All right, so the only one that works was this very first one. -2, -4. And we had 50% of our students get this correct. So right down the middle, 19, 16, 15. Now, what's interesting about this one right here is you can only get this if you do two things. If you take your 2 and you move it 4 to the left, and then you take your -4 and move it up 4, that's how you get your -2, 0. So they applied the the 4, they went over 4, and then they went up 4, right? And that's more than just 4 units away. So the students that got this thought they needed to apply that 4 to both, which is definitely a misconception. When we're doing this 4, it's only going to be to the x or to the y, not to both. And so this was probably right in the middle of the test, 17th hardest, but that 50% means it's just kind of right in the middle of difficulty for our students. For number 11, we are ordering rational numbers. This is 6.2D, and we've got a drag and drop here, and 2 points, one for each blank. We're trying to put these quantities in the correct order. Now notice they're showing it to us not as a list, but as a series of inequalities. But we've got our lowest number because this is less than everything, and then our highest number over here. So we can think of it really like a number line. So let's just kind of extend our number line here. Let's put negative 2.6 right here. Let's put 12/7 right here. And if that's going to help us, I'm going to make this 1 and 5/7. So that's almost 2. But I know 7 is a really strange denominator. So instead of making that a decimal, I'll change that to a common denominator if I need something that big. So, like, I need to think about this 1.9. Which side is that going to fall on? Well, that's going to be 1 and 9/10, right? So where does 1 and 9/10 fall with 1 and 5/7? I'm pretty sure 1 and 9/10 is going to be larger. Let's change these to 70ths. I'll change each of these. And that's going to be 1 and 50/70ths, and then 1 and 63/70ths. Okay, so then 1 and 9/10 is going to fall on the outside. We don't need that. Let's look. I've got my 1/10 somewhere, so I'm going to put my 0 right here, and then my 1/10 just a hair past that. So I need something between this 1/10 and 12/7 or 1 and 5/7. And so my two options are here and here, which means I've only got this negative here. Well, this might be smaller than 1/10, so maybe on this one. So these are my two options. I know it can't be this negative, so let's go ahead and take a look at this 0.025. All right, so this is thousandths, okay? So this is going to be 25 or 0.25 over 1,000. Now, how do I make this 1/10 into thousandths? Well, I can multiply this by 100, right? Or I could just move the decimal place over twice. That's 100 thousandths. So this 25 thousandths actually fits right here, which means that 0.025 is actually going to go right here to the left of 1/10. All right, so that's going to be smaller, which means it can't be this negative 9, 2. Now, negative 9 over 2, if you divide 2 up, that's going to be negative 4.08. So that's definitely too small, which means this 1/8 needs to fall right here. And that does make sense. We can use reasoning there. They're both unit fractions, 1/10 and 1/8. And as my denominator gets larger, my fractional pieces get smaller and smaller because I keep cutting that same hole into more and more pieces. So eighths are actually larger than tenths, so that's going to work. All right, so those are my two correct answers. How did we do? We had only 29% of our students get both points. We had 32% of our students get 1 point. All right, and so we had 45% get that correct if you take half of that 1 point. This was the 14th hardest. And I really do think that one of the things, or at least tied for the 14th hardest, I think one of the things that really tripped up our students is there was one number that was negative, and that was just begging to go right there. But all you had to do is change that into, that was 4.5, not 4.8. All you had to do is change that into a decimal, and you would have seen that that was going to be less than the 2.6. And it doesn't make sense. This 1/10 looks really close to 0. And it doesn't make intuitive sense that that 0.025 is going to be less than that until you make them into decimals, or in my case, I made them both into fractions. And so I think it was not necessarily the knowledge, but it was just really tempting to just put this negative 9 halves right here, and then that would have messed up some students. Number 12, we are multiplying and dividing positive rational numbers. This is 6.3e. And we've got Josette. has 178 coins that are each worth 5 cents. What is the total value? All right, so I've got 178 groups of 5 cents. So I'm going to multiply them. I could add 5 cents 178 times, or faster way would be multiplying. Now, I'm going to put the point 0 there just so I remember it. You don't need to multiply by 0. I'm just going to multiply by this 5. So that's 40, 35, 39, and that's 8. Now I'm just going to keep that there so I can know that there are 2 digits behind the decimal. So I need 2 digits behind the decimal. So I've got $8.90. And if you happen to know there's 20 nickels, because that's what those are $1. So we can use a little bit of number sense here to kind of see, well, 20, 40, 60, 80, 100. That's 100 nickels makes $5. So almost 200 nickels would almost make $10. That makes sense. So our answer here is A. And we had 64% of our students choose that, which is decent. Now, what's interesting is that we had 18% of our students choose C. And what this is 178 divided by 5. Now, it's not even divided by 0.05. It's just plain old divided by 5. And so they did the wrong operation, and then obviously they misplaced the decimal. And so this would be an opportunity to reinforce with students how we understand whether we are dividing or whether we are multiplying. We are looking for the total, and we've got equal groups. Okay, so if you are looking for the total with equal groups, then most likely you're going to be multiplying. If you have the total and then you have equal groups, then most likely you would be dividing. And that's really going to be a deciding factor. Do you have the total or are you looking for the total? For number 13, we are looking at 6.12c, summarizing numeric data. We've got these 6 data points, shows the number of seconds it took for runners to complete a race. We need to find the mean and the median. Now, both of these are measures of center. They describe where within a data set the center is. Is it in the middle? Is it kind of skewed off to the side? And it lets us know kind of what that average student would do or that middle student would do. And this mean can sometimes be referred to as average, but there's no definition and there's no calculation or formula available to us on the reference materials. We need to know how to calculate this on our own. And mean is the sum of the data, the calculation is sum of the data divided by the number of data points. So that means we need to add everything up. So 15.1, 13.8, 12.9. We don't have any calculators that we can use. That comes in 8th grade, which means we're going to have to do this by hand. So whenever I add, I'm looking for tens. 10, 23, 24. Let's look for tens. 5, 10, 26, and then 2, 3, 4, 5, 6, 7, 8. 86.4. Now I need to divide this 86.4 by the number of data points, and I've got 1, 2, 3, 4, 5, 6 data points. So then we just divide like normal, one digit at a time. It's 24. We'll do 24 again. Let's make that 14.4. And if we were to need to add zeros, we would keep adding zeros. We would not use a remainder here, but we don't need to. We've got 14.4, 14 and 4 tenths. That is our mean. Now our median is going to be close to that. It might be the same thing because I could still use 14.4, or it could just be extremely close. But typically, your measures of center, mean and median, are very close, and sometimes they are the same. What we do with the median is we're looking for the middle, but we can't find the middle unless we line them up. So these two aren't necessarily the middle because they're not in order. Let's put them in order. So 12.9 Then I've got 13.8. And then I've got 14.3, 15.1, 15.1, and then 15.2. Now, if it is an odd number, it's easy. You just find that middle number. In this case, your middle is right here. There's 3 on one side, 3 on the other, which means your median is actually the mean of your two middle numbers if there's an even number in the data. So I've got to do the mean. Again, I've got to find the middle number. Now, I can add those two up and divide by 2, or we can use number sense. If I'm trying to find the middle, what's the difference between here? The difference is 0.8, right? If I add 0.8, I'm going to get from 14.3 to 15.1. What's half of 0.8? That's 0.4. So then my middle number is going to be 14.7 because that's 4 away from 14.3. That's 4 away from 15.1. So if you're just trying to find the mean of two numbers that are fairly close, or the median, excuse me, you can use that reasoning as well. So they're close, but they're not identical. The median is 14.7. And when there's an even number of data points, your median can be a number that is not even listed. It could be outside of the data. So we only had 28% of our students get 2 points. We only had 29% of our students get 1 point. So that's 43% correct. Very low. And we had 43% just get nothing. This is our 13th hardest item on the test, and there's a few reasons most likely for it. First off, it's a lot of work. Look at all this calculation that you see me do here. Obviously, one wrong move and I mess everything up because there's a lot of adding and dividing. That's assuming I even know what these two words mean and how to calculate them. So we need to spend time calculating and put them both in the same problem. So we have to differentiate between the two. Sometimes we spend all our time on median, and we spend all our time on mean. We always keep them separate. So let's put them together to see how students are going to do. Next, number 14, we are looking at wholes, parts, and percents. This is 6.5b. And we've got an employee. We have a salary of 36,000, and we need a 3% increase. So what is the amount of the salary's increase? Okay, so I need 3% of 36,000. So it's going to be a lot smaller. So I'm thinking these two are too big because that looks like more like 10%. So I'm thinking it's going to be one of these two. Because if you take 10%, right, you just move the decimal over 1, right? And so look at that. 10% would be 3,600. So these are even bigger than 10%. Okay. Now, there's two ways that I can calculate 3%. If 10% equals, move the decimal place over 1, then if I take 10% of 10%, right, that's 1%. So 1% equals 360. Well, why do I need to find 1%? Well, if I multiply that by 3, I'm going to get 3%. So I'm going to get 1080. Or if you don't want to do it like that, you can just change your 3% into a decimal because that's what 3% is, right? 300ths. And then you just multiply that by your starting salary. 36,000. There we go. You're still going to get that same number, a whole bunch of zeros. You don't need to multiply, but you do need to bring the decimal over twice because there's two digits behind the decimal in the factor. So either way, we're looking at a raise of $1,080 C. Now, only 31% of our students got that correct. Look at this, 35%. More than the correct answer got B. We got a decent amount here for D. So how do we get these incorrect answers? Well, this is 36,000 divided by 3. That's not how you take 3% because 3% does not equal 3. 3% is the same as 3/100ths, right? So we're multiplying by 3/100ths. If you want to divide, then we have to invert that to 100 over 3, but now we're doing, two different operations, and that doesn't help. And then we've got the same thing. We've got 3,600. Now we're just dividing it by, this just drops a 0, right? 30. So this over 50% of our students thought the correct operation to use here was division. When we're taking a percent of something, you need to know that that means we're going to multiply. So step one is to identify what is the correct operation. Step two is to obviously, use it in that calculation. But it looks like a majority of our students are struggling with percent of something and that actually means to multiply. This was our fifth hardest item on the test. For 15, we are looking at equations for area and volume. This is 6.8c. And so we have just this simple setup here. We've got a parallelogram. I don't know much about this parallelogram. They do tell us the area equals 33 square inches, but then they don't give us anything other than that. They say the base is B. We've got a height of 8, which doesn't really help us. And we need to find h. How do we find h? Well, all they give us is area, base, and height. So how does that help us? If we look at our reference materials, we see that the area of a rectangle or a parallelogram is area equals base times height, so it's the same thing. So here's the formula that we have access to. A equals B8. The only thing I really know is that my A is 33. So I can substitute in that 33 for the A, and since A is 33 and A also equals BH, I can now say 33 equals B8. What I want to do is I want to solve for h. So how do I get the h by itself? Right now the h is being multiplied by this b. Well, I could use the inverse property. The inverse property of multiplication says that if you multiply anything by its reciprocal, it becomes 1, right? So 8 times its reciprocal equals 8 over 8, which just equals 1. In this case, I want to multiply both sides by 1 over b. Now, you have to do both sides because if you want to maintain a balanced equation, whatever you do on one side, you have to do on the other side. Now, what does that do for me? Well, this is going to be 33 times 1 over b, or this can become 33 over b. Over here, I'm going to kind of rearrange it here. I've got b times 1 over b times h. If I combine those, that's going to be b over b times h. What's b over b? Just 1. What's 1 times h? Just 8. So basically what that does is that cancels it out. Now my h is going to equal 33 over b. So it needs to look like this. But this is a 1-point problem and it's an equation editor. So I'm going to go ahead and need to type this in. There's no A, B, C, or D for me to choose from. So this is what I'm going to do. I'm going to hit my fraction button. It's going to start in my numerator. So I'm going to hit that, but then down underneath, you notice I've got to hit that B. They gave me that B, which normally they wouldn't, and that's going to work. So that is the correct answer. And if you think that's difficult, you are correct. This is the hardest item on the test, 13. That is correct. A 1 and a 3. 13% of our students got this correct. Not only is it difficult to just solve for A, because that really is, or solve for H. That's really something that we're going to be doing starting in 7th grade and 8th grade a lot more. We could get there using the inverse property. even just typing it into the calculator can be a little bit intuitive. They might have done the 33 first and then try to hit that button, which would have made it look like this. If you hit the 33 and then you hit this button, it's going to look like this, like you're wanting to do a mixed number. So it's not the most intuitive to hit that button first. So this definitely is challenging for our students, and they need to practice not only solving for a particular variable, but then how to enter it into this type of problem. Next, number 16, we are looking at fractions as division. This is 6.2e, and we've got Lizelle with 60 strawberries, equal number into each of 4 baskets. Okay, so here we go. We have a total, and we have equal groups. So if we have a total and we have equal groups, which always means multiply or divide, if we have the total, that means we're going to use that total as our dividend, which means we're going to divide. We're trying to figure out how many are in each basket. So I can say 60, my strip diagram here, and I've got 4 baskets. Here are my baskets. My question is, how much goes into each basket? So I would just do 60 divided by 4. I'm looking for the one that does not represent. So they give you the one that you expect to be the first incorrect answer, because I want one that does not work. That's the one that most of us are familiar with. All right, so now, how else can I show 60 divided by 4? Well, take a look at this. Here's my 60. This is good old long division that we learn in 4th grade. That's your dividend, 60. Your divisor goes right there. So this matches. We don't need this. So I'm left with 2 fractions. Which one of those also means 60 divided by 4? Because that's the one I do not want. And it's this right here, because we know our answer is going to be 15. If I look at B, that's actually going to be 1 over 15. This is an improper fraction that becomes 15. And how do we turn an improper fraction into a mixed number? We divide up. So a fraction is just a division problem that has not been completed yet. So we can show division in 3 ways, and that is the standard 6.2e. We can show it with a division symbol, we can show it with long division, and we can show it in fractional form. All 3 of these mean the exact same thing, which can be confusing for students, which is why it is a standard, because we need to internalize these 3. So our answer here is B. That one does not work. And we did pretty well on that. 61% of our students got that right. Now, 24% chose D, and they might have gotten stuck with this not, right? Now, I don't know why they would have chosen D rather than uh, B. Maybe these two look kind of similar in regards to if you read it from left to right, it's 4 into 60. If you read it from top to bottom, it's 4 over 60. Maybe they thought those were equivalent. But this one definitely is probably going to be the most used form of division. I mean, if you're not doing division by hand, you're not going to see division notated like this anymore. And then this starts to become less and less useful. And really, this is the one that we need to use. So as teachers, one way that we can easily teach students this standard is to just, every time we come up with a division, rotate the different ways that we can express it. And so that they just get used that the one is equal to the other is equal to the other. Definitely on the easier side. This was the 11th easiest item on the test. Number 17, we are looking at 6.9a. This is writing one variable, equations and inequalities. And so we've got this problem situation here. We've got Kevin has a maximum of $28, and he's going to spend it on, looks like, the movie ticket and then the rest. So this is our unknown. All right, so we've got $15 for a movie ticket right here. We've got this Y, the popcorn and the drink, which is the rest. And then we've got the 28 bucks. All right, so setting it up like that. So let's look at it like this. 28, and we're not going to do equals, right? Because we don't have those options here. And we're not trying to equal $28. We're trying to look at all possible values that we can use on popcorn. Well, what do we know? That we know that we've got to take this $15 away if we're wanting to try to figure out what it is, right? So it's going to be up to 13 bucks. If you spend more than $13, you don't have enough money, right? So you can spend anywhere from zero if you don't want to get anything up to 13 bucks. But what does that look like here? Well, we've got our $15 that we have to spend. And then we want to add that to however much that we can buy on popcorn and drink. And the question is does it have to be greater than 28? No, that's my maximum. So it has to be less than $28. Now, my question then is which one of these? Less than or equal to? Well, can it equal $28? Yeah, because he has $28. He just doesn't have $28.01. So you could do less than or equal $28. So that's where this 13 would work, right? $15 for the ticket, up to $13 for the popcorn and drink, and we're good to go. So that's going to be 15 plus y is less than or equal to 28. And did you notice that I can only put an addition or subtraction there, and I can only put one of the four inequalities there. So they do kind of limit the choices. But we just needed to move those two. This was a 1 point problem. Even if you get one of them right and the other one wrong, it's an incorrect inequality. So this is a 1 point problem, and only 30% of our students got that. This is probably one of the most challenging types of problems because what we have is what the standards call a verbal description or a word problem, and we need to make sense of it, right? So matching up by color the different quantities would help. And then before I just put it into an equation, I made sense of it, right? I made sense of it like, well, I've got 28 bucks. 15 bucks is already gone, so that leaves me $13 for the popcorn. So knowing that helps me make sense to double check to see that this really does work here. So this was definitely hard. This was, in fact, our fourth hardest item on the test. This is going to help with a few strategies, but honestly, a lot of practice and a lot of experience where they see this again and again and again. For number 18, we are looking at 6.2b. This is absolute value. And, what's the one big idea for absolute value? We want students to know that -6 absolute value is the same as 6, right? Because when we're looking at absolute value, we're simply looking at the distance away from 6. So this is 6, or distance away from 0, so that's 6 away from 0, just like +6 is 6 away from 0. What happens if you have that? A lot of times, we don't necessarily show the absolute value of a positive number. Well, how far away is 6 from 0? It's 6. So how far would 6.28 be from 0? It would be 6.28. Just like -6.28 would be 6.28 away, right? So that absolute value just changes the sign to make it positive, doesn't change the value. So our answer is super simple. It's going to be this 6, let's get that right, 6.28. And yet, so many of our students were looking for a trick. We only had 68% of our students get this, which is pretty good, but there's no calculation here. We're just recognizing. We had 24% of our students choose B. They looked for a trick, and they spent so much time probably finding the absolute value of -628 that they didn't spend enough time with the absolute value of +628. They probably thought, they were the inverse of each other. If the absolute value of -628 is +628, maybe the absolute value of +628 is -628. Obviously, we know that's wrong, but we need to spend as much time on the absolute value of positive numbers as we do negative numbers. This was easy, but not necessarily as easy as it should be. We had This is the seventh easiest item. A few people chose that, a few people chose this, but really the big distractor was B. Number 19, we are summarizing numeric data. This is 6.12c. Now this is going to be a little bit easier than the last time we saw this. We had to do the median and the mean. At this point, we're just doing the range. Now the range is the difference between the greatest and the smallest, or the greatest and the least. But it doesn't work unless we put them in order, or at least identify what is the greatest and the smallest number. I'm going to put them in order. So I was going to put 12 first, but then I found that 10. That's why we put them in order. 10, 12, 14, 16. That's it for my teens. We got 20, 24, 26, and then 34, 42. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so I'm just simply looking at the difference between 42 and 10, and that's going to be 32. So our answer there is B, but only 60% of our students got this. I mean, that's a decent amount, but we had 16% choose C, 13 here, and 10 here. So this is our biggest distractor. Problems like this, they're going to want to find the difference between the first number listed and the last number listed. 34 minus 16 equals 18. But as we know, the first number listed and the last number listed are not the least and the greatest. So students that fell for C were just trying to remember, okay, first minus last, but they didn't put them in order. So this was on the easier side. This was tied for our 12th easiest, but not necessarily as easy as it probably should be. It all comes down to this word range. If you don't know what range means, right, take a look at our answer choices, 13, 16, and 10. The answer choices that we chose that were incorrect definitely showed an equal distribution, which means even though some people might have fallen for this, we're probably just guessing, which means we don't know what this word range means. We need a lot of practice to differentiate range, median, mean, mode, interquartile range, all of those things. Number 20, we are multiplying and dividing positive rational numbers. It looks like we've got a fairly simple calculation here. We've got 8 over 18 divided by 6 over 12. Okay. Now, we work in sixth grade to understand that dividing by a number is the same as multiplying by its reciprocal. So instead of trying to divide this, I know fraction multiplication is super easy. You multiply straight across. So if I can make this look like a fraction multiplication problem, then my life is going to be a lot easier. And so what I want to do is I'm going to keep my 8 over 18. I'm going to use the inverse. And in order to make the inverse happen, I need to just flip it. So now I'm multiplying by the reciprocal. That's the same as dividing by a number. Now, if I want to, I can multiply straight across, but then, as you can tell, my number is going to get pretty big, right? So 8 times 12 is going to be 96. I don't even know what 18 times 6 is. 48. That's 108. Okay, so I'm going to get this huge number that I'm going to need to, go ahead and reduce multiple times. Now, I do happen to know that I can do this. If I divide by 12s, look, that's 8. We just did that. That's actually 9. So you got your 8/9. So your answer is right here. There's actually a trick that we start to use in 7th and 8th and 9th grade. Let me show you real quick. Is when you get problems like this right here, what we do is we look to see if there are common factors that we can take out of here. Okay? So we look at the diagonals here, or we could go ahead and just simplify these, right? So there's two ways to do it. I'll show you by looking at diagonals. So what is a common factor between 8 and 6? Okay, so 2 goes into both. So 2 goes into 8 4 times. 2 goes into 6 3 times, right? So you can just take a 2 out of both of those. And then out of the 12 and 18, if you look at the diagonals, you can take 6's out. So 6 goes into 12 twice. 6 goes into 18 3 times. Now what do I have? I have 4 times 2, which is 8. And I've got 3 times 3, which is 9. Basically, what you're doing is you're simplifying before you do the multiplication. Because we still had to do all this, but I just did the simplification ahead of time. So that just made it a lot easier. Or some of you might have looked at this before you even multiply. Let's take a look at this. 8 over 18, 12 over 6. Let's just simplify this first, right? I can simplify that if I divide by 2. That's 4 over 9. And then 12 over 6, that's just 2 over 1. So you get 8 over 9. Either way, do your simplification first if you can. This makes it a lot easier. So our answer here is D, and only 35% of our students chose this. We had 30% of our students choose A. We had 19 and 15. So what was it about A? Well, with A, students most likely remembered that division and multiplication are related, but what they did is they just changed the division to a multiplication, but they didn't invert the 6/12. They just left it as 6/12. And what you end up getting is a number that simplifies to 2 over 9. And then what we have here on B is they knew that you needed to multiply and they knew that you needed to flip. But what they ended up doing is they ended up flipping the first one. 18 over 8 times 6/12, and that gets you B. So it might not be as easy as we seem when we divide by a fraction or by a number that's the same as multiplying by the reciprocal. We need to remember we're only changing the second term. We need to do it right because the other ways of doing it are both answer choices that students chose. This was definitely difficult. This was tied for our sixth hardest item on the test. I mean, 35% of our students chose that. Almost as many chose A, which means a lot of people that chose D probably just guessed and they just got lucky. It was definitely on the more difficult side. Number 21, we are looking at our 6.8D. And what we need to do here on this 6.8D is we need to find two figures that have the same area. And so it seems like it's going to be pretty easy. I've got some basic shapes here, but if you really look at it, this is an awful lot of calculation. So when we're looking at our area and volume here, obviously we're dealing with just area, but 6.8D deals with both. I've got to do a lot of calculation. And so let's look at our reference materials, right? Let's make sure we get all of our formulas that we need. So I need the area of a triangle. So I'm just going to put TR for TRI for triangle, 1/2 base times height. I do see a rectangle. Now they don't give me a square, but I need to know that a square is a type of rectangle. And then my trapezoid, that's the one that's a little bit strange. It's like the triangle, but I have to add the two bases. Okay, that's all I need there. But I need to go ahead and calculate every single one of these. If I just try to eyeball this, it's not going to work. All right, so let's look at figure J. So that's my trapezoid. So that's going to be 1/2 base 1 plus base 2 times height. So that's going to be 1/2. My base 1 is 4. Base 2 is 12. And then my height right there is 7. So 1/2, and that's 16 times 7. Let's go and do 1/2 of 16. That's 8 times 7. So that's 56. All right, so 56 square centimeters. This is going to be just base times height. So that's 4 times 13. All right, so 4 times 12 is going to be 48. Add 4 more. and you get 52. So it's not those two. All right, so I've got my 1/2 base times height. My base is 7. My height is 12. I want to go ahead and just take 1/2 of 12. So that's going to be 6 times 7, 42. All right, so I've got 3 different ones right now. So I'm definitely going to have to look at this bottom row. So 21 times 21 is a lot. But I could tell you, I'm not even going to mess with that because think about this. 20 times 20 equals 400. So 21 times 21 is going to be more than that. Okay, so that's just not going to work. If I did 21 plus 21, maybe that's 44. I'm not even going to mess with this. So it's going to be this. I just don't know what it matches up to. Now, a parallelogram, right? If we go back to our reference materials, it's a rectangle or parallelogram. So this quadrilateral here, that is a parallelogram, works for rectangles, works for squares, right? Now, we can't take the slant height, so we don't need that slant height. We need to find the correct height. The height is always going to be perpendicular to the base. So this is going to be 7 times 6, which is 42. So there we go. It's this triangle and this parallelogram. Now, that was a lot of calculation. This was a 1-point problem. You either got it right or you didn't. 25% of our students got it right. 75% got it incorrect. This was, in fact, the second hardest item on the test. We had to apply every area formula that we knew. We had to do 5 different problems. And, the trick here is the challenge with the parallelogram is using that 7 as opposed to that 8, because that 8 is the slant height. And so if we use that, that's going to kind of trick us. So we need to make sure that we use the true height and the base. Number 22, we are solving one variable equations and inequalities. This is 6.10a. And so we've got a word problem here, verbal description. We just need to find an inequality that works for this. All right, so we have each avocado costs 65 cents. All right, so I'm just going to draw a little avocado here, and that's 65 cents. Now, how many avocados can I buy with 10 bucks? Well, if I buy another one, that's going to be another 65 cents. And that's if I did another one, right? That's going to be 65 cents. And so I'm going to keep buying them. How many times? N times. Because it says N, that's the number of avocados. 3, 4, 5, 6, 7, 8, I don't know. How many does it take to get me up to $10? Now, I'm not equaling $10. So can I be greater than $10 or do I need to be less than $10? Well, I need to be less than $10 because that's all I have. I've got 10 bucks. Now, can I equal $10? Right? If I have the exact perfect amount of avocados that equals $10, am I good with that? Yes, I am. So I can say less than or equal to $10. So what I need here is I need the price of my avocados times the number that I buy, which is N, an unknown amount, is going to be less than or equal to my 10. And so we see our answer there is C. And we had 20% of our students choose A. That was our most chosen incorrect answer. 17 choose B, 18 choose D, and only 46 got the correct answer. Now, we see here that we had just the wrong sign. And so at least we were able to recognize what is my coefficient, right? What is my unit cost? And then what is my total that I'm trying to get to? And so with these two, I mean, we have the wrong coefficient. They thought it were $10 each. And so that's not going to work. And so this was definitely a challenge. This was the 16th hardest. Before we even get to the sign, we could have eliminated 2 answers if we could have found what number am I multiplying by? What is my unit cost? Right? 6th grade spends a lot of time on unit cost and ratios. So it's 65 cents per avocado. If we could have done that and then matched that up to n, then we could have gotten rid of two of our answer choices. Number 23, we are converting units. This is 6.48. And you see this is a multiple select. So there are two correct answers that I need to select. So let's take a look. I've got length of a wall is 6 yards. I need measurements that are equivalent to yards. All right, what do I know about yards in my reference materials? All right, so I know that 1 yard equals 3 feet. Okay, so let's start with that. So if I've got 6 yards, then what I want to do is I want to break this up here into 6 equal pieces. Each of these are a yard. And it says that 1 yard equals 3 feet. So each of these are going to be 3 feet. All right, so how many feet do I have? Well, I've got 6 times 3, so that's going to be 18 feet. So we can at least get that. But now I need to go into inches. Well, what do I know about yards and inches? I don't know anything about yards and inches based on my reference materials, but I do know feet and inches. 1 foot equals 12 inches. All right, so within this foot right here, or within this 3 feet right here, let's take a look at this 3 feet. I'm going to kind of blow this up here. Here's my 3 feet. All right. Now, within each of those 3 feet, I've got 12 inches. So I'm going to do like this. That's half. And I can do sixths. And if I cut each of my sixths in half, I've got 12 inches. Now, I don't feel like doing that every single time, so let's just use calculation. If that's 12, that's 12, that's 12, that's 36. So 36 inches equals 3 feet equals 1 yard. And I've got 6 yards. So I need 36 inches, 36 inches, 36 inches all the way across. So let's do 36 inches times 6. That's 36, that's 216. So there we go. There's our second answer. All right, so this was a 2-point problem, and we had 51% of our students get both points. And we had 1 point. Probably, I would think that the 18 feet was a little bit easier. Only 1 point, 36%, and we had 13% not get anything. If you take half your 1 point, you add it to the 2 points, we're looking at 69% overall mastery. So this was definitely on the easier side. In fact, it was the 6th easiest item on the test. For number 24, we are looking at 6.3b, operations with integers. And so we've got this expression here, and we need to use our order of operations in order to simplify this. So let's go ahead and have that off to the side. Remember, when we're thinking about this, multiplication and division are equal, and they could be done in either order, left to right. Same with addition, subtraction, and we're going to be seeing quite a bit of that. So if we're writing this, we should be paying attention first to our parentheses. So I'm going to go ahead and put those in blue so we know that those are the ones that we need to take care of first. Now we do have a parentheses over here, but really there's no expression inside there. There's just a number, -4, which means we're just multiplying these two. So really that's acting as a multiplication. So let's take care of our 2 minus 5. So that's going to be 2 take away 5. It's going to actually end up with a -3. And then what I'm left with is -8 times -3 plus 3 times -4. And so we've got two multiplication. We got a multiplication here. We have a multiplication here. And then we have an addition. So let's go and take care of these multiplications. So 8 times 3 is 24. And then a -8 times a -3 is actually going to get you positive 24, because when you have two negatives, or two positives that actually both equal a positive. Now, when I've got a negative and a positive, or a positive and a negative, that becomes a negative. So if they are opposites, they become a negative. If they're the same, regardless, they become a positive. So I'm going to keep this in parentheses so I can just kind of keep that there. So 24 plus negative 12, which I can just reimagine this is 24 minus 12, which means we're looking at 12. So our answer here is B. And this was extremely challenging for our students. Look, we had 35% of our students get the correct answer, 35. We had 25% choose negative 33. We had 27% choose negative 12. We had 12% here. Now let's look to see how we got A and D. So if you ignore this parentheses and you do a negative 8 times 2, you just take care of this first, right? And then you minus 5. And then you, for some reason, you just go ahead and make that a negative 12. That's how you're going to end up with that negative 33. So they just ignored the parentheses and they multiplied first. Then, if you did, kept the negative 8, right? And then you decided you were going to just separate that 3, you would end up like this. If you just said, I'm not sure what's happening with that 3, and so they thought it was a minus 4, you would end up with this right here. So what this lets me know is that we still have some students that are struggling with understanding what happens when you have this negative 8, and then let's just go ahead and put a negative 3 right there, because that's what this ended up being. The implied operation is multiplication. And you see it happened right here. They didn't necessarily see that implied operation, and they saw it right here. They didn't see that implied operation. And so we definitely have some students that are struggling with, if there's a number next to parentheses and there's no operation, what do I need to do? This was our tied for our sixth hardest on the test. And so this is definitely an opportunity for us to have additional advance and additional opportunities to practice with not even any exponents, right? We're just dealing with add, subtract, and multiply, but having that implied multiplication is a challenge. Number 25, we are looking at real world ratios and rates. This is 6.4b, and we've got Liana charging an hourly rate, and we've got 3 hours equals this, 4.5, 5, and then 9. All right, so what would it take to get 9 hours? Now, there's two ways to do this. I'll kind of go the long way, and then if we use our number sense, I'll show you the really easy way. So here's the long way. We find a unit rate. Okay, so let's start with something that we think is easy. Let's start with this. All right, so if I've got $67.50 for 3 hours, I want to figure out what that is for 1 hour. Well, let's just divide up. Let's just simplify this fraction. 3 goes into 67.5 twice. Let's bring down the 7 twice. Bring that decimal up there. And then we've got 5. So 22.50 per hour. So that's going to be our unit rate. Now, that's not our answer. It's not even one of the choices. That's for 1 hour. I'm looking for 9 hours right here. So then I just need to multiply this by 9. 22.5 times 9. Let's see, that's going to be 45. We're ignoring the decimal for right now. 9 times 2 is 18. Add the 4 is 22. Then we got 18 again. And then we've got the 20 because we added that 2. Now I can look at my decimals. I've got 1 digit behind the decimal in my factor, so 1 digit behind the decimal. 202.5, or put that 0 there, $202.50. Our answer here is B. Now that was quite a bit of work. It's a much easier way if we look at this connection. Look, if I double 4.5, I'm going to get 9. So why don't I just double 101.25. I can multiply by 2, or I can just add it to itself. Either one works. Look what you're going to get. The exact same answer. So either one of these works. You could have actually taken this 3, and you could have multiplied it by 3. And if you did 67.5 times 3, because 3 times 3 makes 9, you're going to get the same thing. So there's many ways to solve this problem. And this was on the easier side. This was tied for our 14th easiest item on the test because we had 58% of our students choose that. So almost 60%. And then we had 16, 13, and 13. So we definitely had some people get really close, right? Or think they got really close. So if you got the 16%, what you did is you subtracted these two right here. So I'll show you in blue. You subtracted the 101.25 minus the 6750. That ended up as 33.75. So this ended up being a 1.5 difference right here. And then they just added that to the 112.50, which is this right here. And then they got the 146.25. But this 3750 is the difference between 1.5, right? That's a 1.5 hour rate, and then the 112.50 is the 5-hour rate. So really, they ended up figuring out how much it would cost for 6.5 hours, but that's not quite enough. So they were thinking that they could use the numbers there. They weren't necessarily thinking the unit rate, but they obviously still struggled there. Number 26, we are looking at annual salaries. This is 6.14H, personal financial literacy. Got to do a little bit of math here. How much more? So we're going to compare a sound engineering technician earn over a period of 5 years than a journalist. Okay, so let's figure out what the difference is for 1 year, because this is an annual salary, so that's 1 year. So 67090, 62,400, and we're going to subtract these two. That's 6. All right, so 4690, which is an answer choice, but that's for 1 year. Now we need to multiply it by 5 because we're looking for 5 years. That's the difference for 1 year. Let's find the difference for 5 years. Let's see, that's going to be 45. So we're going to put a 4 right there. 30, 34, 20, 23. It's $23,450 over 5 years. That is our answer. And we had 51% of our students choose this. 20% chose B. And then 17% chose A, 13% chose C. So, how did we choose A? Well, we took the two numbers, the 67,090, the 62,400, and simply added them. And you're going to get this right here. How did we get this 4690? Well, you already saw that. We subtracted them, but then we didn't multiply it by 5. So there are ways to get those answers, but our best answer is obviously the correct answer, D. And this was actually right in the middle of the test, but technically the 18th most difficult item on the test. Number 27, we are looking at additive and multiplicative relationships. 6.4a. This is a multi-select, so this is one in which we need to select two different answers, and this is a 2-point problem. All right, so we need to find one that's correct. So when x is negative, both values will be negative. All right, let's just choose a negative one. Let's test it in. So y equals 7 and x is going to be -1. So y equals -7. All right, we're good there. And then y equals x plus 7. So -1 plus 7, y equals 6. Nope, I can still have some negative values for 6 all the way up through 7 and keep the y as either, a 0 or positive. So that is not it. Let's check this one. The value of y in this is 7 times the value of x. All right, so y is 7 times the value of x. So they're basically saying, does 7 times the value of x equal 7x? Yes, it does, because between a letter and a number is an applied multiplication. And the value of 7 in y equals x plus 7 is 7 more. Okay, so y equals 7 more than x. And that's what they're thinking. And yes, 7 more than x means 7 plus. So this one is a correct statement. Let's look at this next one. The value of y in both y equals 7x and y equals x plus 7 is 7 times. No, this is not 7 times. This is 7 more. I just figured that out, so that's not going to work. The value of y in 7x is 7 more. No, this is exact opposite. This is supposed to be 7 times, and this is supposed to be 7 more. All right, so that's completely backwards. So I'm assuming it's going to be this last one. When x is positive, both values of y will be positive. Let's do a positive 1. Y equals 7 times 1. Yes. Y equals 1 plus 7. Yes, both of those check out. If you're going to stay positive for x, both y's, no matter what you do, even if you do like a fraction, it's going to stay positive. All right, so our answer there is option 2 or option 5. You might call that B, E. How did we do? Well, we had 36% only get 2 points. We had 51% get 1 point. Now, we don't know which one was the easier one, which one was the harder one, or possibly it was a mixture of both. We had 12% get nothing. Now, if you take half credit for that 1% or that 1 point, you're going to get 62%. So overall, it ended up being okay. I definitely think that this is a little bit easier to read. This one might have been a challenge because we had to think of mathematical relationships in words, but that's actually the best way to describe these two relationships, these two equations. So we need more time with this. And so we can just give our kids this y equals 3x plus 2 and just give kids an opportunity to describe that in words. How would you describe that relationship? Well, you could say y is 2 more than 3 times the value of x. If we can get our kids used to saying things like that and describing it in words, we'll give them more opportunities to be successful in 6.4a, additive and multiplicative relationships. This ended up being on the easier side, 10th easiest item on the test. Number 28, we are looking at order of operations and prime factorization. So this is 6.7a. And we just have this expression here. Let's once again write this down. Parentheses, exponent, multiplication, division are equal. And subtraction are equal. So we've got 4 layers here. All right, so I'm actually going to take care of that exponent first. There is a parentheses, but there's nothing inside. There's no operation inside the parentheses. So really, once again, that parentheses is just showing me that I'm going to be multiplying that there. But since there's no parentheses, it's this exponent I need to deal with first. All right, so what does 3 squared, or 3 to the second power, mean? Well, what that really means is you're going to take 3 and you're going to multiply it by itself 2 times. So really, that's 3 times 3. That's all 3 squared means. 3 times itself 2 times. If it was raised to the power of 3, it would be 3 times itself 3 times. 3 times 3 times 3. So you take the base, you multiply it by itself as many times as that exponent tells you to do, in this case, just twice. So that's just going to end up being 9. So we can come back down here. We got 5 minus 2 times 9 plus 4. So I've got a subtraction. I have that multiplication still sitting there in addition. I still need to take care of that multiplication. So what is 2 times 9? That's going to be 18. And I'm left with 5 minus 18 plus 4. Addition and subtraction are equal, so even though there's an addition over here, it doesn't matter. We can go ahead and do that subtraction first. So 5 minus 18 is going to be negative 13. And then I'm going to add 4, and that's going to get me negative 9. So our answer here is C, and only 35%. So problems like this are definitely giving our sixth graders challenges this year. And so this is an area of growth that we can continue to lean into, to use order of operations to simplify. And this could be prime factorization. 6.7a sometimes asks you to do that as well. And so how do we get 29% of our students choosing 31? Well, what they might do is they might subtract first, right? If you do this 5 minus 2, let's rewrite this here. And then you subtract this first right here. What you get is you get 3. So that ends up being 3 times 9. Let's see, that's a 4. So you get 27 plus 4, which is your 31. So you see the challenge here is they just literally went left to right. They didn't even use the order of operations. They just went left to right and they ignored everything. And that's how you got that right there. If you wanted to look at the negative 27, what you ended up doing was you ended up doing this 5. And then what we ended up doing is we ended up multiplying first 2 times 3 squared, right? Plus 4. We end up multiplying this first, right? So that ends up being 5 minus 6 squared plus 4, right? And then you could just simplify that, and you're going to end up with that negative 27. You should get the 5 minus 36 plus 4, and that's basically negative 36 plus 9, and you get your 27, right? Negative 27 right there. So we've got some misconceptions here. There's a lot of different ways that you can do this, but only one way to do it correctly. And this definitely became challenging for our students. This was tied for our sixth most challenging. And some of the students that we got here might even have been guessing. All of this just kind of makes me think that we've got some rampant guessing going on and that we need to spend a little bit of extra time working on this. For number 29, we are looking at interpreting numeric data. This is 6.13a. All right, and I'm going to scroll this down here so we can see we got a histogram, and then we've just got to make sense of this histogram. Let's go ahead and put numbers here. So a histogram is just like a bar graph. You just have a range in each of these bars, right? So 0 to 49, 50 to 99. And I'm going to put my numbers here. 15, that is 30, that is 35, that is 50, and that's 30. All right, so let's use these numbers to go ahead and just write some statements here. The number of customers who drove 150 miles or more, okay, so 150 miles or more is going to be these two right here. So that's going to be 80 because that's my 30 plus my 50. Because I need to include both of the two rightmost bars, 30 and 50, to get the 150 miles or more, is the same as, so there's my equal, the number of customers who drove less than 150. Okay, what's my 150 or less? 15 plus 30 is 45, and then add that to 35, that's 80. Okay, so we're saying 15 plus 30 plus 35 is equal to 50 plus 30. That looks legit, so I'm thinking that's it, but obviously we need to check the other ones. More customers drove 50 miles than drove any other distance. Well, first off, we can't evaluate this. I have no idea how many. We might have had 0 people drive 50 miles because we don't have exact numbers. We have a range of 50 to 99, but that literally could be 30 people that drove 60 miles exactly. It's within a range, so we can't do that. We have no idea how many people drove 50 miles specifically. We just know how many drove 50 to 99. And even if we wanted to say that 30 is not the most, 50 is the most, so that doesn't make any sense. The number of customers who drove 50 to 99 miles, okay, 50 to 99 is 30, is less than the number of customers who drove 200 miles or more. 30 is not less than 30. 30 is equal to 30, so that doesn't work. And then let's try D. More customers drove 30 miles than drove any other distance. First off, I have no idea who drove 30 miles. It's within this range. No one might have driven 30 miles. They might have driven 28, 29, and then 31. So we can't evaluate that on a histogram. So our answer is indeed A. And we had 55% of our students get this correct, so that's not horrible. Definitely going to put us on the easier side here. We did have 27% of our students choose C though. So let's take a look back at that. And so one way in which we might have thought about this in order to make this correct is we might have thought about 50 and 99 instead of just looking at 30, we might have just looked at the values. Look at this. 50 is less than 200, right? 99 is less than 200. Therefore, the people who drove 50 to 99 is less than the people who drove 200. You see how we could have gotten there rather than evaluating it as a bar graph, they just looked at those labels and said, oh, both 50 and 99 are less than 200. And so that's not correct, but that is a big distractor. This was our 18th easiest item on the test. For number 30, we are looking at properties of operations. This is 6.7D. And so we need to move correct answers. We need to find two that are equivalent. All right, so what I want to do is I want to rename this one right here. So this is the distributive property. So 7x times 1 is going to be 7. And then look, what is x times 1, right? X times 1 is just x. So really, that's just 7x. I don't really see anything that looks like anything times 1 is itself, so that's the identity property. So you could just get rid of this times 1. So really, that's just 7x. I don't see anything else that looks like 7x. I do see something that looks kind of similar, but this is now the distributive property. Let's look at this one. What this lets me know is I can take this x and I can multiply it by both of the terms on the inside, but it's different because you need the addition in there to use the distributive property. This is the identity property. This is the distributive property because we've got that addition on the inside. So this means I can do 7x plus x. You take that x and you multiply by both. So the first part works, the second part doesn't. So I'm not thinking it's going to be those. Let's take a look at this. 7 divided by x plus 1. All right. So order of operations mean I need to take care of my division before I do my addition. How can I write 7x? Well, you can write it like this. 7 divided by x, because remember, fractions can be used to denote division problems. And we can do it like this. So this can look like this. And you notice those are my other two options, and this is the other one that's correct. So these two are actually equivalent. And you can put them in either order. You can do it like this, and it will be marked as a correct answer. Or you can move this one over here and this one right here. Either way, get you the correct answer. This is a 1-point problem, and only 28% of our students got this correct. So this is hard. This was our third most difficult item on the test. And really, I do think when we're discussing this, we need to think not only identity property, distributive property, commutative, associative, but just how we recognize division. That's another standard that we use a lot in 6th grade, and how we can recognize division in fractional notation, because that was what we needed to know in order to solve this correctly. Number 31, we are looking at triangles. 6.8a, and we just need to find a set of measures that make a triangle. Now, if we know one thing about triangles, this will be a super easy problem. If we don't, we're just guessing. And we had a lot of students just guessing. What we need to know is that the angles of a triangle equals 180 degrees. Every single triangle in existence equals 180 degrees. And so if we just add these up, we're going to get 140. So that's not going to work. Now, the next one equals actually a parallelogram or a quadrilateral because that's 360. A four-sided shape, a quadrilateral equals 360 on the inside. This is 90, this is 135. And this is, there we go, there's my 180. So that's my answer, but that's the one thing we need to remember about triangles. Interior angles always equal 180 degrees. Now, we only had 41% of our students get this correct. We actually had 25% of our students use this, and they might have been tricked with those are all three the same. They might have thought, well, I remember my teacher talking about an equilateral triangle. So if they're all the same, maybe that makes a triangle. Well, no. If it's an equilateral triangle, it needs to be 60, 60, 60, because even an equilateral triangle has to add up to 180 degrees. But if they're all equal, it needs to be 60, 60, 60, because 60 times 3 makes your 180. So this actually was a harder question. This was the 10th hardest because there's not really much of a calculation. You just have to add these up here. What it is, it's recognition of the definition of a triangle. And it's one of those kind of like vocabulary. You either know it or you don't. Number 32, we are balancing a check register. So this is 6.14c. And we have the beginning balance here, and we need to drag and drop. So this is a 2-point problem. Our items in here. All right, so when we withdraw, what happens when we withdraw? Well, withdraw means we're taking money away. Deposit means we're adding money. So that's the difference that we need to keep in mind. So if I'm taking money away because it's a phone bill, you're paying money, that means you're losing money. So we need to take our 563 and we need to take away $50 because we're paying $50 for a phone bill. So basic subtraction here, we don't even need to regroup. So 513, 18. That goes right there. Now we can verify to see whether we did that right or not because we're going to deposit, putting money into it. Let's add 2529. That's going to be 17, 4, 8. All right, so this matches up, so we're good here. Okay. Now, I deposited something, and now it went up to 546. So what I want to do is I want to subtract my new total, 546.36, from what I had, 538.47. That's going to tell me the amount that I actually deposited. So I need to use that inverse operation. That's 9. That's 8. Lots of regrouping on this one. That's 7, 0. All right, so just $7.89. It's going to get me up to 546. And if you want to, you can verify. We can put 789 right here to make sure we get to that same one. And that's going to 6, 546.36. Okay, so 789. Those are my two answers. And that just talks about how a check register worked. And for 2 points, we had 43% of our students get both, 34 get 1 point, and then 23 get nothing. So you put these together, half credit for that 0 points, you get 60% of it correct here. So this ended up being slightly on the easier side. This is our 12th easiest, or tied for our 12th easiest. And really it comes down to knowing how does the check register work, but we could have used this clue right here. Deposits means plus, withdrawal means subtract or take away. Number 33, we are ordering rational numbers. This is 6.2d. And we've got a table of values here. We've got some negatives, some positives, some decimals, and a fraction. We just need to go from least to greatest. So we could go ahead and build a number line to kind of encapsulate everything we need here. And I'm going to go ahead and make sure that these two go over here. So -1/4, -0.86, maybe in that order, maybe not. And then these three are going to go over here. Now, look at the positives. I've got 0 point, 0 point, and then I've got a 1 point. So that's going to be pretty easy. If I make that 1, if I make that -1, I can tell you that this 1 point is going to be larger. So 1.02 is going to be my largest, which it is for everyone. So that doesn't super help us a whole lot. Let's go ahead and take out our two positives, right? I got 0 0.3 and 0.18. Well, let's make them both look the same. Let's add zeros to the end. So now I've got 30 hundredths and 18 hundredths. Well, 30 is more than 18. So I'm going to put my 18 here, and I'll put my 0 0.3 here. So I'm looking for 0 0.18, 0 0.3, 1.02. And now I'm left with these two, and these two are incorrect. So really just it comes down to these two negatives. Now remember, two things. One, we need to go ahead and make them both look like decimals. So -1/4, that is a benchmark fraction. 1/4 is 0.25, so it's -0.25. And we need to remember that the absolute value is going to be helpful here, right? What is the absolute value of each of these? Well, 0.25 and then 0.86. That tells you how far away it is from zero. So 25 hundredths away from zero is not nearly as much as 86 hundredths away from zero. So let's make this -1/4. And so the larger the number, the farther away it is from zero. So I'm looking for these two right here. So that's my answer, A. Now, we had 56% of our students get that one correct, and 23% choose B. That was our most chosen incorrect answer, and you can probably guess the only difference was the negatives, right? And so some of our students still struggle with negatives. They could possibly struggle with changing -1/4 to -0.25, but that is a fairly common fraction that we work with. So most likely it is that idea of the greater the negative, the farther away it is from zero, which means the less it is. The bigger the negative, the smaller it is. That's kind of counterintuitive, and some students might still struggle with that idea. So that just takes practice, an opportunity to explain to their peers, possibly use that absolute value to really describe the distance from zero. That might help them place them in the correct spot. Ultimately, this was tied for our 16th easiest item on the test. For number 34, we are once again graphing on the coordinate plane. This is 6.11a, and we are pretty simply trying to find this right there, that ordered pair. So x and y. All right, so our x is going to be -3. Here's our x value. X always comes first, so -1, 2, 3. It's going to be right here. There's only one that's on the x equals -3, but let's go ahead and check our y is -4. Our y values up and down. In this case, down 1, 2, 3, 4. So point R is our answer. If you know your x and y, then that is really easy. And in fact, our students did very well on this, 76% correct. As you can imagine, we had the second most chosen answer was point P, which is really close. And what that is that's -4, -3. And so the students might have just flipped those two values or gone really, really quick. Ultimately, this was not difficult at all. This was the third easiest item on the test. They tend to get a little bit easier as you get to the last few, which is where we are. Number 35, we are looking at fractions, decimals, and percents. This is 6.4g, and we need to simply find something equivalent to 5/4. Well, first off, we should know that 5/4 is greater than 1. So I'm looking for things that are greater than 1, and C is gone. Now, let me go ahead and just rearrange this. If I'll even use a picture if that will help. So I've got 1/4, 2/4, 3/4, 4/4, 5/4. But I can also just say, you know what, this is one whole right here. And that's how we can rename 5/4 as 1 and 1/4. If you have it with a really large number and you don't want to draw a picture, you simply divide up. Divide your denominator and your numerator. 4 goes into 5 one time. Your remainder is your numerator. Your denominator stays the same as your divisor, so that works as well. So 1 and 1/4. I don't see 1 and 1/4, but now let's change this into a decimal. Okay, so the 1 is, well, just 1. What is my 1/4? Once again, benchmark decimal. We just looked at it, 0.25. So add the 1 and the 0.25, you get 1.25, 1 and 25 hundredths. Our answer is A. And 72% of our students were able to get that. So that was a fairly easy item. The other answer choices were just kind of guesses because there wasn't one that really flipped out. This was our 5th easiest item on the test. So we're coming in kind of for a soft landing here at the end of our test. And we get to number 36, our final question. This is representing ratios and rates, 6.5. And we've got a necklace here. 6 red, 10 black. So let's go ahead and just do this. 1, 2, 3, 4, 5, 6. 10 black. Let's do 1, 2, 3, 4, 5, 6, and then 4 more. 1, 2, 3, 4. Okay. Which ratio represents the number of red to the number of black? Well, I've got 10 black, I've got 6 red, and I want this ratio right here. I want the ratio of red to black. Well, if you write it like a fraction, you can treat it like a fraction. And if you treat it like a fraction, you can simplify. They're both even. Let's divide by 2. And look at that, 3/5. Also, an easy problem to kind of end our test with. 64% of our students were able to get this. We actually had 17% choose C. That was the most chosen incorrect answer. I would have expected it would have been A because that's just the inverse. But a lot of people did this. They took their 6 and their 10, and instead of making them as a fraction, they just added them. That's your 16. And then uh, they did their red over their 16. So this is our red to the total as opposed to red to black. And then they simplified to 3/8. So they probably didn't label. I didn't necessarily label, but I used colors to kind of label it for me. Labeling is extremely important to help us keep our ratio because it can be part to part. Sometimes it's part to whole. We need to know the difference between the two. This is tied for our 8th easiest item on the test.